All right, guys, welcome back to Wired Roots. Today we got a simple one for you, the three-way light switch. It's something that's confounded even, professional electricians. So we're gonna break it down for you. We're pulling it out of a 25-year-old 4-H series. It's called Electric Excitement. I got all three books here for you. I've done two of the projects already, so this is the third part. We're gonna set it up on our bench over here, and we're gonna explain to you why it's not complicated whatsoever. And we're gonna add just a little bit of modern flair to it. So let's get after it.
All right, now we're gonna set up our project board. We've chosen to use a wood project board just because most people have it lying around, and I'm gonna show you how to do the wire wrapped screw type, just because it's easier versus a prototype board. And then we're going to lay out everything that we have that we're going to need. We got carrier wires, we got number 4 screws, switches, LED, resistor, I'm going to use my Dremel, there's our battery. Because I don't have the snap-on, we're going to use some alligator clips and smart triggers. So this part's important, positive, negative. And on the LED, let me get it up here real close. These ones do not have flats on the side. But your long end is your positive, and that will correspond to the positive terminal. All right, so what we're going to do is drill holes on all these. I just got a small drill bit here and some number 4 screws. What that's going to allow us to do is just position this as we see fit. Instead of cardboard, I thought wood would be a little more fitting. So let's get these holes drilled. All right, we're gonna get all of these started, and then we're gonna wrap the wire around them. Okay, the important part here is our carrier wires. This is the part that I guess confuses most people on our setup for a 3-way switch. And strip off a little bit more. All right, so we're gonna bend these. Remember to keep track of your positive terminal. We're gonna do this, let me get it up close, orthogonal bends, so that we can just stick them right underneath of there and cinch them down. We're not gonna tighten them yet until we get our circuit complete. All right, we're gonna switch over to some black wire. And I'll include this wire in a link in the description. It is very thin wire. Here's an example that you can wrap around screws. It's non-braided, so the braiding makes things very difficult for prototyping. This is also the right gauge that you can use for breadboarding. I avoided the breadboard because the breadboard is usually fairly confusing to people, so we're gonna stick with a true project board for this. Make sure you leave some extra. Now, there's a rule to setting this up, and orthogonal lines is going to be your friend. Perpendicular, parallel, everything running in 90-degree. That goes for wiring anything. So perpendicular lines really become important whenever you're in high frequency noise immune areas. But here, it is not for physics, it is for functional and more pleasing to the eye and the judge. So if you want it to look good, you're going to want to make all of your lines perpendicular. So now this one's not going to be perfect. I would recommend going through and drawing out exactly where you're going to put all of them. Okay. There's that. And you know what we're gonna do? We're gonna come over to a positive and a negative terminal as well. I didn't mention, this Dremel Micro, this thing is fantastic. I would recommend pilot drilling everything here. And what this is gonna allow is future use of the same board. I know I didn't use the old board just because I had a new one laying around, but you'll be able to turn it into essentially like a pegboard and utilize it for all of your future projects. You could even color code what you're doing off of them so that each color of the hole would have a specific project that you're setting up. And again, we're not using breadboard. We very well could have, but oh, see, I hooked that up wrong. We got to switch those. Positive's going to be on the bottom. That's why we're doing it in pencil. I'm just so used to drawing your positive on the top. So I guess in case that wasn't clear, I have my positive terminal coming in here on my LED. So I need my positive down here. And we're going to leave a little bit of extra. I always tend to leave too much extra. You're better off to get it tidy right to the edge of where you need it. See, yep. Even whenever I wire electrical boxes. I think that, until they invent that wire stretcher, that's probably going to be a habit of mine, is always a little long. Funny story, my wife thought a wire stretcher was a real thing, and she said, "What aisle is it in?" At Lowe's. I had to tell her it was not a real thing. Oh, see, I didn't even put those in a straight line. That's going to bug me. Guess the thing we can do is show you how to make it into a straight line here. Everything orthogonal. Snip off a piece of this. This is going to be a prime example of how to compensate for mistakes such as that, because we're off by about 1/2 of an inch. Alright, so we're stripping off about 3/4 of an inch. Okay. Now what we're going to do is bring it up. We'll get these bend radiuses a little tighter here. But come up and then fix it in place and pull it straight over. And it'll look like we did it on purpose. Now, for the switch, we're going to use differing resistors since we have an LED. The LED, if we drive it with a 9-volt battery, we're going to have issues. I chose to do all of this in black and then the carrier wires in red to demonstrate the carrier wires and how they work with your switch. We're going to hook up our battery here. Okay, we're going to hook up the positive here. And because we don't have a switch on yet, we're not going to get any light. I'm just getting it hooked up, getting ready. Okay, now you'll see, let me flip this around. We have our minus going to the top and our plus going to the bottom. All right, we got our LED cinched down, and what we're going to do here is install our resistor. This could be at the bottom of the steps and the top of the steps. And we're just going to use a piece of wire on this side. Okay, here's a point of explanation that I need to go through. So the reason I did it with this setup, so that you can actually see with both of these open. That way you can control both of them open and both of them closed. With normal switches, you actually it's very hard to get your switch to stay in an open state. As a kid, you probably sat there and rocked a switch until you hear arcing in the middle. Obviously not safe to do. Maybe that was just me as a kid. But the idea here is you're able to control where you're at. So we're gonna go all the way up to the top carrier. So these are your 2 carrier wires. This is, let's say, at the bottom of the steps. And the top of the step is already closed to one position. So we're going to move it and flip it from the off position, see no light. We're going to flip it to the up position, and now we have complete circuit. Okay, so switching back and forth. So now if you're at the top steps and you come, you know, and you want to turn it off while you're at the bottom. All right, so any combination of these two will turn the light switch on. So in principle, this is the core to a two-way or three-way switch. It's two wires, your carrier wires, and this DC demonstration, to me, really made it click. And I'm going to put something up on the screen here now to show what is actually in the book. The book does a pretty decent job of explaining this. From this project, I decided to go with an LED. Just it's a little more modern twist instead of an incandescent, since they're outlawing incandescence. The next thing that we're going to do is go through a few different resistors. So I was thinking of going through the color coding and explaining that, but that's pretty boring. So what I want to do instead is show you the best way to measure. So I have a resistor here. Let's just say I don't know what it is. And actually these resistors are some cheap ones. They're like 5% resistors, so they're pennies a piece. And if you're looking for a good kit to get your kids, there's a lot of simple kits out there. This one, it comes with a ton of LEDs, Arduino stuff. You know, I forget how much it was. I'll put a link in the description. It's very nice because they come with just strips. So there's a 330 ohm. We may use that one instead of the 220. So with it, you come. What's nice is they're labeled, so you can pop one off. But once you get one off, now you need to know what the resistance is. So we're gonna hook it up to our multimeter here. All right, so when you're using your meter, there's all sorts of different settings on here. We're gonna come down to the one that looks like a horseshoe. That's the omega symbol, which means ohms or resistance. And resistance has no polarity. It'll measure across no matter how you hook it up. And this is the easiest way to check where we're at. So we're at 10K, all right? So without the meter, you'd have to look at the color codes on here, and these ones are impossible to read. I need a specific color of light to even read it. So we're gonna do the 10K. All right, so we just did that. Now we're gonna pull off a 1K. Reason I'm doing this is I want to show you that we can. Let me move this meter. Okay. So we're gonna wire this one up, just like we did the other, and we're gonna hook it up to the bottom. And now you'll notice how much brighter this light is. Let's zoom in a little bit here. Okay, so we're gonna switch this, go back, and just like that, we have created a three-way switch off of a 9-volt battery, a resistor, and an LED. So let's go even further. Now the LEDs are rated for a specific amount of current. That is the reason that you have to use a resistor. You'll burn them up, and the best thing to do with the LED that you hooked up wrong is throw it away, because it'll cause you points of confusion. So let's just see how bright this one is. Oh my goodness, yeah. So there is our 330 ohm. It may not capture well on the camera here, but it is much brighter.
So here's a side-by-side comparison of the three resistors we just used. On the left, you see the 10K allowing only 0.6 milliamps, so less than 1 milliamp of current. And on the right, you see the 330 ohm resistor. That's more appropriately sized. Check out this LED calculator. I'll leave a link in the description below. It allows you to click the question mark beside the LED voltage drop so that you can select the color of your LED.
In essence, that is a three-way switch. We've covered some very simple concepts here. You know, orthogonal wires, carrier wires, resistors, how to measure your resistance, the positive and negative of LEDs, using a 9-volt battery, using screws and your wood as your substrate. This is just a simple video for you guys. If you enjoyed it, like and subscribe, and I'll bring you a few more of these out of this archive that I've dug up. Thanks, and we'll see you next time.